So let's see this question. Mod of x minus y, is it greater than mod of x minus mod of y? Now if you look carefully, the left hand side is mod of something. That means it cannot be negative. It can only be positive or 0. And the right hand side is some mod minus another mod. It could be like mod of 5 minus mod of 3. It could be mod of 3 minus mod of 5, let's say. So it can be positive as well as negative. Both the things are possible for the right hand side. Let's see, first statement, x greater than y. So let's say 5 is greater than 3. So in this case, 5 minus 3. Now if you see, the left hand side would be equal to right hand side in this case. Question is the left hand side bigger than right hand side? This says no, it's equal. So it's a no case. While if you take x as minus 3, y as minus 5. So the left hand side would be this, and the right hand side would be this. Now if you see, the left hand side is always positive, but the right hand side in this case is negative. So it can be a yes case also, not sufficient. Second statement, x into y is negative. So that means they have opposite signs. So again, let's say x is equal to 5, y is equal to minus 3. So the right hand side becomes 5 mod of 5 minus mod of 3. Two values are getting subtracted from each other. That's what is happening on the right hand side. And the left hand side is 5 minus minus 3. So the values, in terms of values, they are getting added. So this is bigger and this will always be bigger. Okay, even if you take let's say x minus 3, y 5, the left hand side would be, the values are getting added. On the right hand side, the values are getting subtracted. So again, this will be bigger. So it's always bigger. This is sufficient. B is the answer. Now if we have mod of A equal to mod of B, so mod means value, okay, positive value of A is equal to positive value of B. That's what it means. So it could be mod of 5 equal to mod of 5. It could be mod of 5 equal to mod of minus 5. Okay, value wise they're equal. In terms of signs, they might be same, which is A is equal to B. In terms of signs, they could be opposite signs, like A is equal to minus B. Okay, for example here, A is equal to minus B. So same sign is one case, A is equal to B. Opposite signs is another case, A is equal to minus B. So we'll take two cases. For example, in statement 2, mod of x minus 3 is equal to mod of 2x minus 3. Okay, so one mod is equal to another mod. In this case, we'll make two cases. A is equal to B, they're exactly equal. A is equal to minus B. This is another case. Okay, so from here we'll get x is equal to 0. That's a no case. From here we'll get x is equal to 2. That's a yes case. So not sufficient. First statement, mod of x plus 3 is equal to 4x minus 3. Again, take two cases. So x plus 3 is equal to 4x minus 3. X plus 3 is equal to minus of 4x minus 3. So here again you get x is equal to 2. That's a yes case. From here you get x is equal to 0. That's a no case. But if we have mod on one side and variable without mod on other side, like this, then we'll have to plug in values and check. For example, x is equal to 2. If you plug in this, it will satisfy. So 2 is a valid answer. But if you plug in x is equal to 0, it becomes the right hand side becomes negative. Mod cannot be negative, so 0 is not a solution. So for this to be true, only one value satisfies, x is equal to 2, which is positive, so that's a yes answer, sufficient. A would be the answer. I repeat, mod on one side, variable without mod on another side, like this, we'll have to plug in the values and check. Okay, while if we have mod on both the sides, we don't have to plug in, no need to plug in. I mean, if you try 0 and 2, both will satisfy this, so we don't have to plug in. Now mod of x is equal to 2, let's say. So what it means, value wise x could be 2, x could be minus 2. Okay, in terms of value it will be 2, positive 2. But if I have mod of x, let's say less than 1, this is the situation. Now let's say x is equal to 0.5, so this will satisfy it. X is equal to negative 0.5, this will also satisfy it. Yes, but if we take a value outside this window, okay, let's say if we take 1.5, so mod of 1.5 will be bigger than 1, so it will not satisfy it. And if we take mod of minus 1.5, still this will be bigger than 1. Okay, so what it says is, in terms of value, okay, it is less than 1. Okay, so it could be anything between 1 and minus 1. So that's practically what it means. Okay, so you'll see a lot of questions where it says x mod of x less than 1. So we're checking whether x is between minus 1 and 1, or simply saying, does x lie within this window? Okay, so this is 0, this is 1, this is minus 1. So mod of x less than 1 means x lies within this window, and if we have mod of x greater than 1, that means x must be outside this window. Okay, value wise x should be more than 1, so that's what it means. So again the question is, mod of x less than 1, does x lie between 1 and minus 1? That's what we're checking. First statement, it is mod of a equal to mod of b. So we'll take two cases, a is equal to b and a is equal to minus b. Okay, so from here you'll get x is equal to 3. That's a no case, it's outside this window of minus 1 and 1. From here you'll get x is equal to 1 by 3, which is a yes case, which is within this window of minus 1 and 1. Second statement, mod of x minus 3 is greater than 0. Now mod is either positive or 0. Okay, greater than 0 means x is not equal to 3. That's what I get from here, because see, if x is equal to 3, mod of x minus 3 will be nothing but 0, so it doesn't satisfy it. But if you take any other value, like x is 1, so x is 5, all the values to the either sides of 3 would satisfy it. Other than 3, everything would satisfy. So not sufficient. I mean, other than 3, this is 3. Other than this, it could be within this window, it could be outside this window. Not sufficient. If we combine the two, first statement says x could be 3 or 1 by 3. Second statement says x is not 3. Now only one value of x, which is 1 by 3, will satisfy both. So this is sufficient. If you remember, r square can be written as mod of r into mod of r. So this question can be simplified as r square upon mod of r can be written as mod of r into mod of r upon mod of r. So now the actual question becomes, is mod of r less than 1, or is r between 1 and minus 1? It's within this window or outside this window? Is r is more than minus 1? This is 0, this is 1, this is minus 1. So r is to the right of minus 1. Now within this window, answer would be yes. Outside this window, the answer would be no. So this is not sufficient. Second statement, r is less than 1. This is 0, this is 1, this is minus 1. R is to the left of 1. Again, within this window it will be yes. Outside this window it will be no. So not sufficient. Combine the two. It says R should be more than 1 but less than 1. Okay, R should be more than minus 1 and less than 1. So it's between this window. That's what combination says. This is sufficient. C is your answer. Is mod of n less than 4? Is n between 4 and minus 4 within this window? That's what we are checking. Now first statement says n square is more than 16. So I can write n square more than 4 square. A square more than b square is given. Both sides are positive. So A could be positive, A and B could be positive. It could be that one of them or both of them are negative. That can also happen. But one thing is clear, the positive value of A should be bigger than positive value of B. Okay, value wise A should be bigger because it doesn't matter it's positive or negative. When we do square, it will become positive. So we can write mod of A is greater than mod of B. So here we can write mod of n greater than mod of 4. Mod of 4 actually is nothing but 4. So this is a confirmed no answer. Question was, is the left hand side bigger than right hand side? Statement says no, it's the other way around. So this is sufficient. Second statement says 1 by mod of n greater than n. Now if n is negative, left hand side would be positive, right hand side would be negative. So this will definitely be satisfied. So that means every negative value of n would satisfy it. Now again, it could be within this window, a yes answer. It could be outside this window, a no answer. I mean, it could be minus 1 also, it could be minus 5 also. So this is not sufficient. A is your answer. Now there is one more way we can understand mod. Mod is defined as distance from 0. For example, if I say mod of x is equal to 5, that means distance of x from 0 is 5. But distance can be on either sides. This distance is also 5, so this can be x. This distance is also 5, this can also be x. So x could be 5, x could be minus 5. This is another way to look at mod. Okay, so distance of x from 0 is equal to 5. That's what it means. Now if I say distance x minus 2 is equal to 5, so what it actually means is distance of x from 2 is 5. So this is 2, this distance is 5, so this could be x. This distance is also 5, so this could also be x. X could be minus 3 also, 7 also. Instead of making cases, we can directly jump to this number line. So mod of x less than 1. So distance of x from 0 is less than 1. So this is 0. Distance is within 1. Okay, within 1 distance from 0 on either sides. So x should be between between minus 1 and 1. That's another way to look at mod. There are some questions which are easily done by this. For example, A. Which of the following equations describes the set of all real numbers that are 6 units away from minus 4? So x minus a is equal to 6. Okay, distance of x from a is equal to 6 units. So a is equal to negative 4 here, distance from negative 4. So that's what it becomes. That's our answer. And we can take one more simple case. Let's say x is between 80 and 100. So how do we write x in terms of mod? Now this is 80, this is 100. Get the midpoint. Midpoint is 90. So x minus 90, mod of x minus 90, distance of x from 90. So distance is 10 on either sides. Okay, it should be less than equal to 10. Okay, so if 80 and 10 are included, let's say, if they're included, we'll put equality also, otherwise we won't. Okay, x could be anything between 80 and 100. So with from 90, distance would be maximum 10. It should be within 10. X and y are positive. Is x equal to y? First statement, mod of x minus a is equal to mod of y minus a. Distance of x from a is equal to distance of y from a. Now this is a. Now if x is equal to y, this thing would be satisfied. So it could be yes. And this is a, this is y, this is x. Okay. So let's say these distances are equal. Okay. So distance wise, both are equally distant from a, x and y. But in this case, x is not equal to y. Okay, x and y can be on either sides of a. This is, this would be no, so not sufficient. Second is negative. This alone is not sufficient, doesn't tell me anything about x or y. If we combine the two, this is 0, this is a. Now x and y should be positive. So if x and y both are on the same side of a, to the right of a, so x will be equal to y, and distance of x from a will be equal to distance of y from a. So this can be satisfied. This case will satisfy both the statements, statement 2, statement 1, and the question itself. Now if we take another case wherein this is 0, this is a. Now in this case, x and y were both on same side of a. Now if we take x on the one side and y on another side, this will not satisfy the question condition, which is x and y are positive, because if y is to the left of a, it would be negative. So this case cannot happen, that the numbers are on either sides of a. Only this can happen, and x is equal to y. This is sufficient. C would be the answer. Next, when we have square root, let's say square root of 36. Some people might think it could be plus minus 6. No, it's 6. It's only the positive value. For example, if I say x square, so will the value be x? We don't know, because x could be 5, x could be minus 5, minus 2, anything. We don't know. How do we make sure this is, we need to make sure that the result is positive. So either we write the value is mod of x, or we write x if x is positive, let's say x is equal to 5, or minus x if x is negative, like this case. Okay, because if x is minus 5, minus x will become 5. Okay, minus x will become positive. So we need to make sure the result is positive. That's all we need to check. That's all we need to take care. For example, square root of x minus 2 square. Okay, so the answer should be what? Mod of this number, mod of x minus 2. So if it will be x minus 2, if x minus 2 is positive, and it will be 2 minus x if 2 minus x is positive. Okay, or simply saying, let's put x minus 2 is equal to a. Now this whole thing becomes square root of a square. So that should be a if a is positive, this case it should be equal to minus a if a is negative, this case. Okay, so end of the day the result should be positive. That's what we are concerned with. For example, this is square root of minus x into mod of x. X is negative, so minus x would be positive and mod of x any which way is positive. So I can simply write it as square root of x square. Again, the answer would be x if x is positive, or minus x if x is negative. So x is given as negative, answer should be A. D would be wrong. It's this answer. Again, mod of x minus 5 square is it equal to 5 minus x? That's what we are asking. Again, let's put x minus 5 equal to a, so it becomes square root of a square. It will be equal to a if x is 0. It will be equal to x minus 5 if x minus 5 is positive. It will be equal to minus a if a is negative. So it will be equal to 5 minus x if 5 minus x is positive. Okay, so now if you see, we are simply checking out of x minus 5 or 5 minus x, which one is positive. That's what we are checking. Okay, the result will be either x minus 5 or 5 minus x, depending upon which one is positive. If you see, second statement simply says 5 minus x is positive, so it simply tells me yes, this is positive, so this will be the answer, sufficient. First statement tells me minus x into mod of x is positive. So mod of x is always positive, so minus x should also be positive. That means x is negative. So if x is negative, let's say x is equal to minus 2. So 5 minus x would be positive and x minus 5 would be negative. So again, we know which one is positive, sufficient. D would be the answer.